In this lesson we're going to make a brief comparison between iron and aluminium. First of all, let's just look at the method of extraction. So iron is extracted using a blast furnace. You can learn about this in the lesson on the extraction of iron, and that involves reduction using carbon. We're able to do that because carbon is higher than iron in the reactivity series, but it isn't higher than aluminium. So in the case of aluminium, we've got to use the electrolysis of fused aluminium oxide, which is a more expensive process. Now then, the density. So the density of iron is 7.81 grams per cubic centimetre, whereas the density of aluminium is only 2.7 grams per cubic centimetre. This makes aluminium a particularly useful metal. Its density is nearly 3 times less than that of iron. So combined with the fact that both of these metals have quite high tensile strength, so we can say that aluminium is strong. In fact, iron is in fact stronger than aluminium, but being strong and with this low density makes it very useful for manufacturing aircraft bodies and wings, for example. Okay, so the melting points, well, the melting point of iron is about 1540 degrees Celsius, just a little bit less than that, and the melting point of aluminium is only 660 degrees Celsius. Okay, that's another advantage for aluminium. It makes it easier to melt and easier to cast using aluminium. So malleability, well, both of these are malleable metals in their pure state. That's to say, iron is malleable in its pure state, but the problem is when it comes out of the blast furnace, it's got quite a lot of carbon mixed in with it, about 4%. That's called cast iron, and that's not particularly malleable. So it's malleable, but it depends on the percentage of carbon mixed with the iron. So it depends on the type of steel we're talking about. Okay, so low carbon steel will be quite malleable, but higher carbon steel not so. The low carbon steels tend to be used, for example, for the manufacture of car bodies. Okay, it's quite workable, and that's got round about 1.5% carbon in it. Now, if you want to find out more about the percentages of carbon present in the different types of steel and the uses of those different types of steel, then go to the lesson on iron and steel, also in this unit. Okay, so aluminium is, yes, it's malleable, very malleable, and so for example it's used for pressing cans and used for aluminium foil. You can draw both iron and aluminium into cables, for example. So this is a cross section of a high voltage transmission line. Usually, as we mentioned in the previous lesson, the center core is made from steel because steel has more strength than aluminium, so it's used to support the cable between the pylons. But the outer layers of the cable are made from aluminium, which has a higher conductivity than iron. So iron, like most metals, is a conductor of electricity. It conducts, but the conductivity of aluminium is about 3 times better, okay, than iron, and the conductivity of the iron actually decreases as you increase the amount of carbon that's mixed with the iron. So steel alloys of iron will be poorer conductors of electricity than iron. So aluminium's a good conductor, got low density, really good for transmission lines. Now, last of all, we just talk about corrosion. How easily are these metals corroded? Well, you know that iron has a problem that it rusts easily. It reacts with oxygen and water in the air and the atmosphere to form hydrated iron oxide, which is also known as rust, and which will flake off. So in order to prevent corrosion, iron objects either have to be coated. You can, for example, cover with oil, with paint, or you can galvanize, but this just adds to the cost of using iron. So you've got to look after products that are made from iron to stop them rusting, whereas aluminium is coated with a protective oxide layer. A thin layer of aluminium oxide adheres to the aluminium lattice, it sticks to the lattice, and it prevents oxygen or water from attacking the metal. Okay, so aluminium has this advantage over iron, and just finishing off with corrosion, well, you'll know that another alternative to preventing corrosion is to make an alloy called stainless steel. And that's an alloy of iron, carbon and nickel or chromium, and actually a similar thing happens there as with the aluminium, is that the nickel or chromium, they form very thin oxide layers on the surface of the iron, and these oxide layers prevent further corrosion of the iron. So stainless steel is an alternative for preventing corrosion.